Hello friends, welcome to Shanti-Peace for Mathematics. In my previous video, you have learned about what is Demoros Theorem. A Demoros Theorem is stated as cos theta plus I sin theta power n is equal to cos n theta plus I sin n theta, where theta is any real number and your n, it is an integer. We have extended this result till n is an integer, and also we have shown that the result is true for rational numbers, but if you have taken your theta, it is between the interval minus pi to pi, and also this result is true for any real number r with this condition on theta. We have moved forward for next thing, that is the root of a complex number. So the questions arise that what will be the, if there is a number 1 plus I, what will be the square root of this, or 1 plus I is there, what will be the cube root of that. So to solve these questions, actually the complex analysis is established. We will take as a theorem, for any z non-zero, there exists a value of z which satisfy the equation z power n is equal to z0. That means it is actually a z is nothing but you can say that it is the nth root of z0. So it says that for any non-zero number, there are values of z which satisfies this equation. So to solve this one, what I am taking as z as equal to r e raised to I theta, and I am taking z0 as r0 e raised to I theta 0. Now if you substitute that values into this equation, then what we get is r e raised to I theta power n equal to r0 e power I theta 0. This will I can write as per the Demoros theorem, r raised to n into I n theta is equal to r0 e power I theta 0. Now there are two complex numbers are equal in polar or exponential form. So by equality condition, we can say that r power n is equal to r0 and n theta equal to theta 0 plus 2k pi. That means this is the things that we have derived in our previous lecture. That means if z1 is equal to z2 and r1 e raised to I theta 1 is equal to r2 e raised to I theta 2, if you have, then r1 is same as r2 and theta has a difference of 2n pi, that we have already discussed in our previous lecture, and your this k is belongs to z. You can take any value as an integer you can have. So that means this will gives you r equal to r power 1 by n, that means nth root of r0, and theta that we can have is theta 0 plus 2k pi by n. So that means we can write as the number z, we can write as r0 power 1 by n into exponential of I theta 0 plus 2k pi by n, where k is belongs to z. If you write down this exponential in the form of cos and sine, so that can be write as cos theta 0 plus 2k pi by n plus I sine theta 0 plus 2k pi by n for any k belongs to z that we can have. Now this nth root of z0 is denotes the positive nth root. It is the positive nth root of r0, and the equation z raised to n equal to z0, that solutions are this value, different values of k, it has a different values of z you can have. For example, if k is 0, then you can write down this is as z equal to nth root of r0 into exponential of I into theta 0 upon n, because k is 0 here. And this is called the principal root. This is the principal root of the given equation. Thus, the other equations are, for example, if I have k equal to 1, that I can write as z equal to nth root of z0 into exponential of I into theta 0 plus 2 pi by n. So that I can rewrite as r0 exponential of I into theta 0 by n plus 2i pi by n. If we can consider this principal root as c, this quantity I can write as nth root of r0 into exponential of I into theta 0 upon n into exponential of I into 2 pi by n. See this here I have used that exponential of x plus y is nothing but the exponential of x into exponential of y. Using this quantity we can write this, and this quantity that we have, it is c as we have denoted, c into exponential of I 2 pi by n. So, and if I denoted this exponential of I 2 pi by n as omega, then that is c into omega that you have. So where omega is e power I 2 pi by n. Same way, if you can have k equal to 2, you will have z is equal to nth root of r0 exponential of I into theta 0 by n plus 4 I pi by n. So that's equal to c into exponential I 4 pi by n, and that's equal to c into, if I denote this is as exponential, that is omega square, because the exponential of I 4 pi by n I can write as exponential of I 2 pi by n whole power 2. So that is omega square that we have, because omega that we have denoted as e power I n pi by n. So that is omega. And similarly, if you go further, k equal to 3, you will have z equal to c omega cube, and so on. And for n minus 1, that means if till k is equal to n minus 1, you will have the roots c into omega n minus 1. So, and after that the all roots are repeated. That means if you can have k is equal to n, then it is z is equal to nothing but the c, and so on. So after the n minus 1, all roots are repeated here. So that means what we can say is there are n distinct roots of this equation z power n equal to z0. The roots of this equation are c omega square up to c into omega n minus 1, where what is c, as we already defined, the c is nothing but this, that is a principal root, and omega is e power I n pi by n. So c is nothing but the nth root of r0 into exponential of I theta 0 by n, and omega will be e power I 2 pi by n. So in short, if you have the nth root of z0, if you want to find out, then the roots of that are in this form. So with that we can have some example. So the first example that we can take is find the cube root of unity. To find out the cube root of unity, you need to solve this equation, that is z cube equal to 1, because nothing but the z equal to 1 power 1 by 3. Unity means 1, that you know, cube root of that means a cube root of 1 that you are calculating. So that means you need to calculate the what is the solution for this equation. So first what we'll do is we can convert the 1 into polar form. So that 1 I can write as in form of, if you can compare with r into cos theta plus I sin theta, then you will have r will be square root of x square plus y square. Here if you compare this 1 with x plus iy, you know that x is 1 and y is 0, so that's why this will be 1. And theta that you will have is tan inverse of y by x, so that is tan inverse of 0, and tan inverse of 0 will gives you 0. So that means z cube equal to 1 I can write as cos 0 plus I sin 0. That I can write as cos of 0 plus 2k pi plus I sin 0 plus 2k pi, where k belongs to z. Now, so that means as we have discussed above, what will be the value of z you can have is now is cos 0 plus 2k pi by 3 plus I sin 0 plus 2k pi by 3. If you can take cube root here, so that will be cube root here, and this value, that means you can take it inside, so that will, using the Demoros theorem as we have discussed above, so we can have this is cos 0 plus 2 pi by 3 2k pi by 3 plus I sin 0 plus 2k pi by 3. And what are the values of k? It is till 0, 1, 2, because after that the values are repeated. Okay, so for example, if k equal to 0, if you can have, then you will have z0, that is, if k is 0, that means this is 0, so it is 1, because cos 0 plus I sin 0, so that will be 1. If k is 1, then z0 will be cos k is 1, that means it is 2 pi by 3 plus I sin 2 pi by 3. If I can say this is omega 3, as we have this notation, that we can have omega as a notation that we have denoted, so that will denote it as omega 3. K is equal to 2 will gives you cos of 2, that means it is 4k pi by 3, so it is 4 pi by 3 plus I sin 4 pi by 3. That I can write as cos 2 pi by 3 plus I sin 2 pi by 3 whole power 2, because by Demoros theorem, and that we can write as omega 3 square. Why we have omega 3? Because for cube root we can denote it as omega 3, for nth root we can denote it as omega n. Okay, so these are the three roots you will have: 1, omega 3 and omega 3 square. These are the roots, cube roots of unity that you have. Let us see the geometrically how this cube root of unity are located. So if you have, this is x-axis and this will be your y-axis. The 1, you know that it is here, this is 1, and where is your omega 3 is here, that is omega 3, because the angle is 2 pi by 3. 2 pi by 3 means it is 2 into 180 by 3, so it has to be 120, so it is 90 plus 30, so it is 90 plus 30 you will have, and this is 4 pi by 3, that is also can omega 3 square will be here. So that is the way this cube root of unity are located. Let us try to solve for 6th root of unity. That means we need to solve the equation z power 6 is equal to 1. So as we have shown above, the 1 can be write as cos 0 plus 2k pi plus I sine 0 plus 2k pi. So that means z I can write as cos 2k pi by 6 plus I sine 2k pi by 6. For what is the value of k? You will have 0, 1, 2 up to k n minus 1. Here it is n is 6, so it is till 5 you will have. So it is 3, 4, 5. So these are the values you will have. So now k equal to 0 if you have, it will gives me k equal to 0, then the first will gives you 1 because cos 0 plus I sine 0. K is equal to 1 you will have, then z0 is cos pi by 3 plus I sine pi by 3. If I can denote it, this is as omega 6. Then the other roots you will have is 1 omega 6 square, omega 6 cube, omega 6 raised to 4, omega 6 power 5. So these are the sixth root of unity, and if you can try to draw this on a figure, then you will notice that if this is your x axis and this will be your y axis, then this sixth root of the unity are located on this circle with radius 1. So that is the first root you will have here. The omega 6 you will have here. Then omega 6 square you will have here. Omega power 3 you will have here. Omega power 4 you will have here. And omega 5 is here. So in short, what we can say is all the cube roots of any number, it's located with the respective radius. That means here the radius is r0, value of r0 is 1. So that's why it is located on the circle with radius 1. And it is with the equidistance. That means whatever the distance between this omega cube, so it is located in the similar manner in the complex plane. Now in general, if you have z power n equal to 1, that means the nth root of unity. So what are the nth root of unity? In the same manner you can have is 1 into omega n into omega square up to omega power n minus 1, where omega n is e power I 2 pi by n. Now from this what we can say is this nth root of unity are in the geometric progression. The first notice is they are in the geometric progression. And what will be the sum of this roots? That means what will be the sum of the roots of 1 will be 1 plus omega n square up to omega n power n minus 1. That we can write as 1 minus omega n power n upon 1 minus omega n. This is because of 1 minus x raised to n is 1 minus x into 1 plus x plus 1 x square up to x raised to n minus 1. Due to this we can write this. Now what is omega n power n? What is omega? Is this cos 2 pi by n upon sine 2 pi by n. So that is 1 minus cos 2 pi by n plus I sine 2 pi by n whole power n upon 1 minus omega n is there. But what will be this? N will goes inside. So this is 1 minus cos 2 pi minus I sine 2 pi, and 1 minus omega n is as it is. So this cos 2 pi will gives you 1 and sine 2 pi will gives you 0. So that's why it is 1 minus 1 upon 1 minus omega n. So that will gives you 0. That means the sum of the cube root of unity is 0 and the product is, and they are in the geometric progression. Let's have the another example. Find the all roots of minus 8i power 1 by 3. So what is the question is, find the all roots of this complex number. So if I can compare this with this number with the x plus iy, then you can have x is 0, y is minus 8. So what is your value of r? It is the square root of x square plus y square, that will be square root of 0 plus 64, that is 8. And what is theta? A theta is tan inverse of y by x, so that is tan inverse of minus infinity. And you can see this point minus 8 is stay here, and if you measure the angle is minus pi by 2. Yeah, definitely you can measure the angle from this side, but that is not a principal argument. So whenever you are calculating the root of a complex number, you need to calculate the principal argument, because if you calculate this one, then it is 3 pi by 2, but 3 pi by 2 is not lies in this interval minus pi less than theta less than or equal to theta. Your thetas always should be in this interval for principal argument. So here we are calculating the principal argument only, so that's why it is minus pi by 2. So that means we can write as minus 8 I raised to 1 by 3. I can write as 2 into cos minus pi by 2 plus 2k pi plus I sin minus pi by 2 plus 2k pi whole power 1 by 3. So that will gives you 8 power 1 by 3 into cos minus pi by 2 plus 2k pi by 3 plus I sin minus pi by 2 plus 2k pi by 3. This will gives you 2 into cos minus pi by 6 plus 2k pi by 3 plus I sin minus pi by 6 plus 2k pi by 3. Where what is the value of k? You will have k is running from 0, 1 and 2, because the value of n here it is 3, so it is goes up to 0, 1, 2. And for k equal to 0, what you will have is k is 0, that means this will be z1 if I denoted, that is 2 into cos minus pi by 6 plus I sin minus pi by 6, that is the value of z1. And you can know that the minus pi by 6 is nothing but the cos minus pi by 6 is root 3 by 2, so that is 2 into root 3 by 2 plus I, and minus sin pi by 6 will be minus 1 by 2, so that will gives you root 3 minus I. That is the answer for this. K equal to 1, you will have z1, that is the 2 into cos, that is minus pi by 6 plus 2 pi by 3 plus I sin minus pi by 6 plus 2 pi by 3. Minus pi by 6 plus 2 pi by 3 is actually a pi by 2, that you can calculate. So it will nothing but the 2 into cos pi by 2 plus I sin pi by 2, and you know that cos pi by 2 will be 0 and sin pi by 2 is 1, so it is 2i. So z3 will be 2 into cos minus pi by 6 plus 6 pi by 3 plus I sin minus pi by 6 plus 6 pi by 3, and this will gives you 2 into 7 pi by 6, so that is cos 7 pi by 6 plus I sin 7 pi by 6, that you can calculate and check why it is 7 pi by 6. And the 7 pi by 6 I can write as the cos 7 pi by 6, 7 pi by 6 it is in third quadrant, so both of them are negative, so that's why it is minus root 3 minus I, because it is this value is minus root 3 by 2, this value is minus 1 by 2, and 2 will cancel with this 2, so that's why this is the answer. And geometrically if you try to draw this, then what you will have, this 3 number, that is a cube root of minus 8i, they are in this form. See, first one value is z1, that is z1 is here, that is minus pi by 6. This is the value of z1, that is the, and this radius of this circle is 2, so it is, this point is 2 comma 0, and the second value is 2i, that is the, this value, that is z2, and the third value is minus 7 pi by 6, that is here, so that is z3. So that means also here the all the roots are lies on the circle with radius 2, or any roots of the complex number, it's always lies on the circle with radius vector you will have for that number. Similarly, you can, I am giving you as an exercise this, find the all the roots of minus root 3 plus I power 1 by 5. Okay, now we are solving the one example here. Solve z raised to 4 minus z cube plus z square minus z plus 1 equal to 0. So this to solve this equation, we can observe one thing, z power 5 plus 1 I can rewrite as z plus 1 into z raised to 4 minus z cube plus z square minus z plus 1. So if the question is to solve this equation, so if I solve this equation, z raised to 5 plus 1 equal to 0, that is equivalent to solving this equation, because except z is equal to minus 1, all the roots of this equation, all the roots of this equations are the roots of this equations. So it is actually to solving this z raised to 5 plus 1 equal to 0, that is nothing but the z raised to minus 1 whole power 1 by 5. That means the question is to find out what will be the fifth root of minus 1. So you know that the minus 1 I can write down in the polar form as cos pi plus I sin pi. Again, by taking x is equal to minus 1, y equal to 0, you will have r is 1, theta is pi. That you can check. So that we can write as cos pi plus 2k pi plus I sin pi plus 2k pi whole power 1 by 5. And that we can write as cos pi plus 2k pi by 5 plus I sin pi plus 2k pi by 5. Where k is 0, 1, 2, 3 and 4, because n is pi here, so it goes up to, so it has a 5 roots, so that's why it goes up to 0, 1, 2, 3, 4, 5, and after 5 the roots are repeated. So if you can substitute this value of k equal to 0, 1, 2, 3, you will have different roots of the given equation. So for example, k equal to 0, you will have the roots, first root is z1, if I denoted cos pi by 5 plus I sin pi by 5. K equal to 1, you will have z2, that is cos 1 here, so that's why it is 3 pi by 5 plus I sin 3 pi by 5. K equal to 2, you will have the another roots, that is 3 pi by k equal to 2, you will have is 5 pi by 5, that is cos pi plus I sin pi, and that is the minus 1. And k equal to 3, you will have z3, that is cos, so 7 pi by 5 plus I sin 7 pi by 5, and k equal to 4 will have z4 will be cos pi plus 4 into 2, it is 8, so it is 9 pi by 5 plus I sin 9 pi by 5. So what are the given solution of the given equation is this 4 roots, first root, second root, third root and fourth root. So these are the roots of the given equation that you can have. So that's it for today's lecture. So let us recall what we have did in this lecture. For any number z0, the nth root of z0 can be written in the form of c into c into omega, c into omega square up to c power omega power n minus 1. So all the roots of this will be written in this form, where c is called the principal roots, and the value of the principal roots is r0 power 1 by n into e power theta 0 upon n, and omega is e power I 2 pi by n. So any nth root of z0 can be written in this form that we have discussed, and what we have discussed is this solution of this equation, that means nth root of 1 or unity is they are in the geometric progression. Also we have noted that the sum of that roots of this 1 nth root of this 1 are 0. We have discussed that they are lies on the circle with the radius 1. So lastly, I am giving you one exercise here that you can solve for yourself. Find the values of these two problems. That's it. So thank you for listening me.